Okay. So for the x squared graph, hopefully you already know what shape this is. What shape is this? Yeah, it's the U or the parabola, right? And if you're not sure what all the points are, again, plug in values. If you do 0 and you square it, what do you get? If you do 1 and you square it, what do you get? What about 2 squared? Do you see how I'm getting those quickly? Okay, go on the other side, you get the same thing. So now you get your parabola. It looks something like this. Okay? Here it's similar, except we're cubing numbers, right? Let's start with 0. What's 0 cubed? What is 1 cubed? What is 2 cubed? So all the way up here at 8. Okay? If I go backwards and do negative, a negative times a negative times a negative is negative. So the only thing that changes is instead of 1, it's -1, and instead of 8, it's -8. So now we get this little S-curve type graph. Okay. Absolute value. Okay. What's the absolute value of 0? At 1, absolute value is 2. 2. Same thing on this side. You guys see where these are coming from? Okay. The square root graph. Okay. What's the square root of 0? What's the square root of 1? 1. The square root of 2?
4.
4 times 4 is 2? That's interesting that you say that, though. The square root of 2 is not really a good number to use, right? The square root of 3, still not good. But what's the square root of 4?
2.
So then we get a nice point over here. Do you guys see where I'm getting that from?
Yeah.
Okay. And so we get a graph that looks something like this. You can't plug in a negative into a square root, so you're not going to get anything out of that. So this is it. Okay. Cube root function. Okay. A cube root is like a square root. It's actually kind of like the opposite of cubing something, right? So what were these nice numbers that we got here? We got a 0, we got a 1, and what was this one? 8. So that means when I'm going the other direction, cube rooting 0 makes sense because that's going to be 0. Cube rooting 1 makes sense because that's going to be 1. And the next number that I can cube root is 8, which will give me 2. Okay? Cube roots, you could actually take the cube root of a negative. Okay? So you're just going to get -1 over at -1, and at -8 it'll be -2. So we get a similar squiggly snake or S curve. It's just kind of sideways. Okay? Let me stop here and make sure there's no questions because these other two are a little, well, actually this one's not so bad, but this one's a little tricky. Okay? How many of you have seen at least half of these shapes before? How about all of them? A couple of you. Okay. But do they make sense where they're coming from is the question. Okay. Let's talk about this one, the one that we kind of skipped at the beginning. So B represents a real number, okay? So I'm going to just label, let's say this up here represents B, okay? Is there an X in the formula here? That's the first question. Do you guys see an X in the formula? So that means regardless of what my input is, my output is always this number, whatever that number is. So if you plug in 0, the answer is B. If you plug in 1, the answer is B. If you plug in 12, the answer is B. Does that make sense? So if you start thinking about what that looks like, plugging in 0, you get B. Plugging in 2, you get B. What shape is this? It's a horizontal line. Okay.
Wait, why is it that?
I know it is 3 technically, but I labeled it as B.
Oh.
Does that make sense?
Yeah.
So what you need to get from this is, like if this were a 5, it would just be a horizontal line at 5. Okay. If this were a -2, then it would just be down here at -2. Okay. All right. This next one. 1 over x. What's 1 divided by 0?
Can't divide by 0.
You can't divide by 0. So there is no graph anywhere at 0. Okay? What about when I plug in 1? What is the output? So right here. Does that make sense so far? Let me zoom in because it's going to get a little... What if I plug in 2? What is my output? 1 divided by 2 is a half, not 2. What's 1 divided by 3? 1/3. So what's happening is I get larger over here. This is getting closer and closer to 0. Does that make sense? Will it ever get there? If I plug in 100, is that going to give me 0?
No.
It'll just get really close, right? In fact, I can't even graph that because it's going to look like it's on top of the line. Okay? But what's going to happen is this. Okay? When you plug in a fraction, like let's say 1/2, you're going to get 2. When you plug in 1/3, you're going to get 3. When you plug in 4, you're going to 1/4 rather, you're going to get 4. Okay? This actually has a name, and it's easier to remember with these points if you know. This is called the reciprocal function. Meaning, it just gives you the reciprocal of the input. Do you guys remember what reciprocal means? You flip the numbers. That's all that does. So if I have 5, for instance, what's the reciprocal of 5? 1/5, right? Does that make sense? What's the reciprocal of 1/10? 10. So do you see why if we're really close to the x-axis, this gets really steep? Because the reciprocal is going to get really big. Does that make sense? So if you remember, this is the reciprocal graph. You can kind of generate these points pretty quick. I know it's confusing when you start plugging in fractions, but just remember, flip them. That's all we're doing. Okay? Over on this side, it's the same thing, except they're all negative. So we're going to get the same exact picture. It's just going to look something like this. Okay? And because we don't actually hit the x or y axis at all, we have these things that we call asymptotes. Have you guys studied those before? Okay, I know you have. Okay. Asymptotes are just, in one word or another, or one way to explain it would be they're lines that we get really close to on the graph. So as we get further and further out, do you guys see how these lines represent where the graph is headed? Okay? Same thing near 0. The asymptotes would be this flat horizontal line at y equals 0, and also this vertical line at x equals 0. Okay? Any questions on these shapes? Okay. So next, and I think it depends on how much you did of that little review that we did kind of halfway through our previous course. Let's see how this goes. So domain. This should not be the first time you're hearing that word. Who remembers what domain refers to?
All x values.
All x values. Okay? So if I'm looking at this first picture, a good way to find the domain, since x values are left and right, okay? If we start on the left, what's the smallest x value we see? negative infinity. There is no smallest x value. This thing keeps going forever, right? If I go to the right, there's really no place that this stops either. Does that make sense? So the domain here would be all real numbers, okay? And in interval notation, we use the parentheses with the negative infinity and positive infinity listed like that. Range, instead of x values, now we're focusing on what? Y values. Well, looking at my picture, what is the only y value on this graph? B. So we're just going to say the range, and fancy notation would be to use these braces. When we have a single or a couple of numbers, you would list it that way. Okay? There's actually more complicated notations too, but that's good for that. Do you guys remember interval notation? Should we review that real quick?
Yeah.
We should review it? Okay. So before we fill out the domain and range, let's go down to the bottom here. Just a quick recap on the interval notation. Let's just say I have a number line, okay? And it looks something like this. Interval notation, we use parentheses or brackets and use sometimes. So these are the options when we're talking about interval notation. We either use parentheses, brackets, and sometimes we use a U if we have more than one thing going on, more than one set. Okay? Parentheses are used whenever we have open circles or omitted values. These brackets are used whenever we have closed circles or we want to include the points. So included values or omitted values. Okay? So if I'm looking at this number line, okay, from left to right, we always read our number lines from left to right. What is the first number of my graph? What's the first number that I'm coloring in here? 5. Is it filled in? So that means I use a bracket to start the interval notation. And then I separate it with a comma. And do I stop anywhere? I keep going forever. So how do I say that? Infinity. And whenever we have infinities, we always use parentheses. Okay, those aren't actual values, so we can't use brackets. We have to use parentheses. Okay?
Yeah.
I know we talked about this a little bit, but yes?
What does it say under open circles?
Omitted values. Okay? Now, let's try a more difficult example. Let's go over here. So I'm kind of cutting this off a little bit because I'm running out of space, but how many sets, how many pieces do you see here? 2. Okay, very good. So let's list the interval. What's the first thing, the first number I start with as I read this from left to right? Negative infinity, and so that must have a parentheses. Okay? Do I stop anywhere?
Yes.
Where do I stop?
Negative.
-1. So I'm going to list that next. And is this included or not? So that means we use a parentheses with it because it's not filled in, it's not included. Okay? And since there's more, that's when we bring in this u. This u really just means or union, okay? Where's my next starting value? At 2. Do we want to include that one? So that's a bracket. And then where do I stop? 5, and that should be with a parentheses. Okay, if this kind of makes sense, that's really all we need to understand for interval notation. Okay? So here's what I'd like for you to do, and then I'll kind of go over these with you guys. If you could look at your pictures. So maybe, do you want to do one together? Let's do this one. Let's do this third one together, and then I'll let you guys try the other ones before I go over the answers. Okay? Domain is from left to right. Range is from bottom up. Does that make sense? Left to right for domain, bottom up for range. So if I'm looking at this parabola, what's the first or the leftmost x value? Negative. Well, here's -2. Doesn't this keep going? So technically, this keeps going forever to the left. We just can't do it, right? So we would have negative infinity. And do I stop anywhere? So this goes to positive infinity. In other words, this is all reals again for the domain. Okay?
If there's an arrow, is that it every time?
Usually there's going to be an infinity involved, yes. Yes, that's a good question. Okay? Now let's do the range. Going from the bottom up, what's the first y value that we hit? 0. And then do we stop?
No.
So this would be 0 to infinity. Bracket for the 0, because that's definitely a point there. It's not like we skip that value, right? And this goes forever to infinity, so then we just close it with a parentheses there. Okay? Take a couple of minutes. Oh, yes?
So is the range all y values?
Yes. Yes, exactly. Range is all y values. Domain is all x values. Yes?
You know how in the first one, the constant function,
Yep.
you use the squiggly lines, not the brackets?
Yes.
Why'd you use those?
This is a special circumstance because there's a single value for the range. It's not like from this value to this value with a bunch of little values in between. Yes. Yes. Okay, so take a couple of minutes, you guys. See if you guys can figure out the domain and range for these other pictures. Okay? And then I'll go over them in about 5 minutes.
But this implies that you hit zero. We're actually skipping one. So you have two separate numbers for the domain, separate sets. I mean, if we're talking like how accurate it is, I mean, we just have two should actually
No, that is way too high. Like that is asking to be mandatory. But then he said nah.
There was necessary to be
Okay. I'm going to put the answers up here, and you're just going to ask away. Like if something's not making sense or you don't understand where my answers are coming from, ask. Yes?
I was just gonna ask if you could like at least explain range because I still don't get that.
Range is just the y values?
Yeah, but like how do we know? Because like I don't know how to use the brackets still. Like how do I know which ones?
If the point is included or filled in, we use a bracket.
Okay.
If it's not included, then we use a parentheses.
Oh, okay.
And it'll make more sense when we start doing like piecewise graphs and things like that. But okay, so here's the domain and range for this is all real numbers for both. Because looking at the picture from left to right, there's no stopping, and same thing from bottom up. There's no separation there. Okay? Same thing with the cubic graph. The absolute value graph is very similar to the parabola. They almost look the same, except that the parabola starts to smooth out, right? So the domain is also all real numbers, but the range is 0 to infinity. The domain for the square root. So finally, something different. The first x value here is 0, and that's included. And we keep going to the right forever, so that's going to be an infinity at the end. And now the range, the first y value, is right here at y equals 0. So again, we start at 0, and this does keep getting larger, just slowly, but so that's also going to be an infinity. Domain for the cube root. From left to right, I'm hitting every value, so all real numbers again. And from the bottom up, I'm also hitting every value. There's no stopping or separation there. Okay? This is the one now that's a little tricky. Okay? So if I start as left as I can, this arrow indicates that I should start with a negative infinity, right? Is there a separation though? Where? At this value, which is 0, right? And since that's not included, that's going to have a parentheses. Okay? And then we're going to pick up pretty much immediately after 0. That's why we have another parentheses here. And then we're going to keep going to the right towards infinity. Okay? The range is exactly the same. If you're looking for different ways to know domain and range, especially domain is just another way to think about what is allowed to be done to x, or with x rather, and what is not. So for example, if we go back to this picture, let's take the square graph, parabola. There is no rule against squaring a number. Like you can square 0, you can square positives, you can square negatives. That's why the domain is all real numbers. Okay? Same with cubing a number. There's no rule that tells you you're not allowed to cube a 0 or something like that. Okay? But when we get to the reciprocal graph, what's one rule you know about dividing numbers? What's one number you're never allowed to divide by? 0, which is why we see this 0 popping up as our separation, because we can't use that value as part of the domain. Okay? Any questions there? Yes?
The last one, I've seen negative infinity and negative 1, and then like small square bracket union, and then the same for square bracket.
1 to infinity?
Yeah.
So the problem with that is when you put a 1 here, that means we're stopping at 1, but technically this graph continues to the right. Does that make sense?
Yeah.
And so what we want to say is that we get to 0 almost. Does that make sense? Okay. All right. Let's turn the page. First definition is the word continuous. A good way to think about something that's continuous is that it's connected everywhere. There's no like disconnects whatsoever. So like this is a continuous function because it's connected. This one is not because there's like a separation in the graph right here. Same thing here. This one is almost all connected. There's a little hole there, so that's why it's also discontinuous. Okay? These are the different kinds of discontinuities. Something that jumps from one value to another is called a jump discontinuity. Anything with asymptotes is called non-removable. And something that has a hole is called removable. Okay, we'll probably touch on those when we come back. Okay. And before I do this graph, I'm going to do a separate piecewise example. And then we're going to stop there. Okay? Let's say I wanted to graph a function that looks like this. X squared if x is less than 0. And let's do 1 over x if x is greater than 0. Oh, you guys can't see that. Okay. So piecewise graphs, it's going to basically be all those graphs that we just kind of reviewed or maybe learned for the first time. It's going to be combining them, sometimes more than one, like 2, 3 graphs at a time, but on one picture, on one graph. Okay? And piecewise literally means that you only graph a portion of the graph. Okay? So real quickly, and I would recommend using pencil to start, there are a couple ways that you can do this. Okay? Some of you that can see what's going to happen don't have to do it this way, but at least to explain why the picture looks the way it is, I'm going to do it this way to start. Okay? What does x squared look like? What is that? That's the parabola, right? So here's x squared. This is just a sketch. Okay? What is this over here saying? What does this mean? How do you read this? If x is Less than 0. So this is telling you, hey, I want you to graph this parabola, but you know what? Only graph the part of it that's less than 0. That's what that means. So if I'm looking at this, which half do I not want? And I don't have an eraser on this pencil, so that's awesome. Here we go. We only want to include the values where x is smaller than 0, meaning I do not want any values to the right of 0. And since this is a less than, not an equal, we're going to place an open circle at the origin. Okay. Do you guys see why I erased part of it and only kept the one side there? Okay. Here, we want to do the reciprocal graph, but for values of x that are greater than 0. Okay. Well, again, here's the reciprocal graph. Looks something like this, right? But we want only the part that is greater than 0. So which part of this do I want? The part that's on the right, because that's where x is positive. Does that make sense? So basically, erase this part. We don't want it. Okay? And so your final graph, now I'm going to use my marker, is going to look something like this. Okay? Does that make sense to you guys? This is tricky, but it'll get easier with time. Here's your homework. And like I said,